Okay, so for question 1, problem set 2, the first question I think is relatively straightforward. It is simply asking you to look at conformations of N-butane. And so the question is, draw the 2 most stable conformations of butane using both the Newman projection and the zigzag projection formalities. And so what does that mean? So this is N-butane, 4 carbons. So the zigzag projection is what we spent quite a bit of time in class dealing with. Right. And so if we want to do the Newman projection, we set up our creepy little eye to look at that. Then we're going to put the methyl group up, the 2 hydrogens down. And we look behind it, methyl group there, 2 hydrogens here. So that's the most stable. And again, this is very straightforward. The second most stable conformation is then when you're going to rotate this 60 degrees. So we set up our creepy little eye. Alright, so in the anti position here, or the gauche position here. Okay. So for part B, the question is, at the right is the conformational energy diagram about the C12 bond of 1-bromo 2-methyl propane. Using the Newman projection, figure out which ones are correspond to which positions on the energy diagram. All right, so if we look at that, I think the first thing that's important to do is be able to draw that molecule. So 1-bromo 2-methyl propane. So that's propane. 1-bromo 2-methyl propane. Alright, so there we go, hydrogen there, hydrogen there, hydrogen there. So then if we draw our creepy little eye, make sure I do this the same way I do on the answer key. Alright, so the substituents on this carbon, you'll have 1 hydrogen and 2 methyl groups. So let's put the methyl groups here, and the methyl groups here. So I think that probably the best way to answer this question is to just go ahead and draw all of the different staggered and eclipsed conformations. All right, so we're going to rotate this 30 degrees. So we're going to take this down. So that's an eclipsing conformation. but one thing is you don't have a methyl group eclipsing a bromide. I'm going to turn it another 30 degrees. This should be of, those should be of identical energies, right? Because they're basically the same conformation. You have this methyl group goes to this and this anti to this, right? Take it another 30 degrees. It's another eclipsing conformation. But now you have this going on. You have a methyl group eclipsing a bromide, so your two large groups are eclipsing one another. So that's going to be higher in energy than this. You turn it another 30. Alright, so now you have two gauche interactions here. So you have two gauche interactions here, which is higher in energy than this. Alright, so then we go back. So those are all the important conformations we need to think about. And then if we were to rotate this another 30 degrees, we'd have another one of these bromide methyl eclipsing interactions. So we can identify the highest energy interactions. So that would be this. And then if you rotate this another 30 degrees, you get this. Right. So these two are equal. Those two correspond to C and E. The lowest energy conformations are when you only have one gauche interaction and one anti-interaction. So that is this and this. And then this medium energy conformation where you have two gauche interactions with this and this. Okay. So the last part, C, draw the chair conformations. I'm not going to really go through this, mainly because I think that I provide an answer key, and this is now up online, and I think this is pretty clear. I think the important thing that I would tell people to do here is that when they're trying to take a structure like this and convert it to a chair conformation, number your carbons. So 1, 2, 3, 4, 5, 6. And then number them over here too. It really helps you be able to take the carbons from here and the substituents in the carbons and translate them over to here. And then trying to draw the two chair conformers of that, I think is just going to be practice. And I'm not going to go through it. I think that's something you should do on your own.